The next use of the diode is in a light emitting diode. So this LED is a heavily doped PN junction, which under forward bias emits spontaneous radiation. So please remember, here it is PN diode and it is in forward bias. Okay, means positive terminal of battery will be attached to P side and negative terminal of battery will be attached to N side. And we know electric field is directed from N to P type. Okay, so when the diode is forward bias, electrons are sent from N to P. Okay, so from here electron will move from N to P. That will be your this current will be majority due to majority charge carriers. Okay, so the electrons will move from N to P, and we know in P majority is holes. Here majority are electrons, so electrons will move from majority area to minority area, you can say. So here in P types, the electrons are in minority. Similarly, the holes will be sent from P to N. So if electrons are moving in this direction, holes will move in opposite direction. So holes will move from P to N. In N, they are minority carrier. Now at the junction boundary, so there will be a junction here. Okay. At the junction boundary, the concentration of minority charge carriers increases compared to the equilibrium condition. Okay, since now more number of electrons are moving, so the concentration of minority charge carriers will increase. So thus at the junction boundary on each side of junction, excess minority charge carriers are there, and these minority charge carriers will combine with majority charge carriers. Okay, N to P. So along the junctions, let's say here excess electrons were there, excess holes were there. So when electrons are moving from N to P type, between the in the depletion region near the junction, there will be some P holes here. Electrons will also be there. So these electrons will go and combine with these holes, and on recombination, the energy will be released in form of photons. So photons with energy equal to or slightly less than the band gap are emitted. Okay. So that is your working of light emitting diode. Means whenever we are applying some potential difference across the diode, then photons will be emitted out. It's just opposite to the working of the previous one we have studied, that was photodiode. This is LED. Okay. Next is LEDs are biased such that light emitting efficiency is maximum. So this is your basic working of LEDs. Thank you.